Hey everybody, welcome to the Corda Architecture Working Group. We're going to go ahead and get started. We have a couple of things covered today, so just a little bit of news. Today's session is going to primarily be on high availability. So we have the engineer who's been leading our effort on high availability capability, primarily in the Corda Enterprise release that's coming up, so R3 Corda. So we're going to run through what that means in the initial release. And then Bogdan's also going to give us a demonstration of some of those capabilities, which we're quite excited for. Just a couple of things to cover off real quick. First off, obviously, Happy New Year, everybody. So hopefully you had passed a great 2017. We had an exciting last year. So 2017 was a very big year for R3 and the Corda team in particular. So if you look at some of our milestones, the biggest one is we put our 1.0 product out the door. So we're quite excited. Hopefully all of you are working with that today. And then quickly move to our 2.0 product. And if that naming scheme doesn't make sense to you, look back at one of our old AWG sessions where we explained our naming strategy, our versioning strategy, apologies. But some other great news, over 800 developers attended our 2-day in-person training. That's a lot of people to train in person. So we're excited to have all of those people as fully qualified Corda developers, in addition to those of you who have been training yourself up online. And we are aware of over 50 Corda apps in a commercial realm that are being developed today. So a lot of momentum, a very big year, shaping up to an even bigger 2018, we're hoping. So the only news part to talk about today in particular is to remind you the developer preview. We are gearing up to ship our first version of the developer preview. For those of you who have signed up, thank you. We will be sending news in the very near future. So probably sometime next week, we'll send out the first newsletter, and we're going to slowly release access to it in a controlled manner. So look for some information on that. But if you haven't registered for that yet, please go to corda.net, and you can see the registration link at the bottom of the home page. If you register, we'll put you in the newsletter, and then we'll send you a unique access code to get your hands on the bits, as well as the documentation and other information. I am going to move very quickly then to pass over to Bogdan, and we're going to cover off on the high availability in R3 Corda Enterprise Blockchain.
Hello, everyone. My name is Bogdan, and I'm a developer on the platform team. I've been dealing with high availability issues for the past couple of months, together with Matthew Nesbitt and Chris Bellington, and I'm here today to present our thoughts on high availability with Corda Enterprise and what we want to do for the future and what we have done so far. So my presentation will go over what high availability is, just a quick recap of the node architecture and what components are susceptible to failure, what steps we have taken to implement high availability, what our current design is. We will go over a proof of concept implementation that we've done with Microsoft Azure. And finally, we will go over some conclusions and, if time permits, a quick demo of high availability with Corda, with R3 Corda. Let's get into it. So high availability, what is it? So it's basically a characteristic of any system which is defined as the percentage of uptime, right? Of the time that the system is functioning. Typically, the goal is to go as high as possible, 99.999%, which is also called the 5 nines. This is achievable, but very difficult. This goal should not be confused with fault tolerance, which is no failure. In reality, no system is really fault tolerant. Not even the giants like Google, Amazon are truly impervious to faults and failures. High availability is achievable by introducing redundancy in software, hardware, and data. And in our case, we've actually done this on all sides, on all fronts. There are several stages of implementing high availability for a system. The earliest one is the cold standby, or hot cold, as it's also known as. In this stage, the primary system is active while the secondary, the backup system, which is identical in every way, is inactive, waiting to be started once the primary one fails. The second stage is warm standby or hot warm. In this stage, the primary system is active, identical backup is inactive, but is syncing up to replicating data from the other one in preparation for starting up. Third stage, hot standby or hot. This is the one that most systems should target. The primary system is active. The identical backup is also active, but not processing any data. It's basically idle. And then the last one, which is active, implies it's basically an enhancement of hot, in which every backup is active in processing data, and there's some load balancing there's some load balancing involved. This last one provides almost instantaneous recovery, which is something that we do want, especially considering that R3 Corda is meant to be used by big institutions, financial institutions, where downtime should be as low as possible. Next, let's have a quick overview of the node architecture. A Corda node is basically a JVM runtime that runs in a Corda network and has a unique identity inside the network. From the diagram, you can see that it has several interfaces with the outside world. The most important one is the network layer, which represents the peer-to-peer connections in the peer-to-peer network. Then we have the RPC layer, which is used by the owners of the node to control the node, as well as Corda apps to control the node and run flows. And then lastly, we have the database connection, which in the plain Corda node uses the H2 database, but for high availability that is insufficient because the database is basically bundled up with the node, and if the node fails, the database fails as well. So in case of severe hardware failure, a lot of data could be lost. We decided, so it's very important to have high availability for the Corda nodes. We have taken several steps and continue doing so in order to achieve this. The first one, and probably the most important one, is allowing the use of a third-party relational database instead of H2. And this is important because third-party databases allow geo-replication, syncing with other databases, which in itself is a form of high availability. So we're basically putting this responsibility on someone else. The second step is the message queue replication, where at the moment we are using Apache Active Artemis, which is a messaging system, and for peer-to-peer connections, we use queues stored on the disk. And then next is the next step that we were exploring is the Artemis HA features. Artemis out of the box offers clusterization, data replication, and shared stores. So this is one thing that we want to explore further. The next step was automatic master selection. In case of a cluster of nodes, we do want to be able to decide which is the primary node, especially in hot, cold, or hot, warm situations. At the moment, we implemented something called mutual exclusion for hot, cold. The next step is to teach the RPC client libraries how to load balance. For example, let's say that we have a primary and a backup node, and we RPC towards the primary node, and that fails. We have to we need the ability for the client, the RPC client, to not know that the node has failed and to be able to send RPCs to the backup. And then lastly, this is something for long term, is to split out the microservices from the nodes gradually and until the node is left with just like bare functionality, and everything else that is taken out can be can have HA applied to it. So what have we done so far? We have been able to implement hot cold, which is the bare minimum for this, for what we want. So far, let's say we had a R3 network with 2 nodes inside, Alice and Bob. If we apply what we've seen so far, we took out the H2 database and deferred it to a third-party SQL database. Then we replaced the Alice node with 2 nodes, one master, one slave, both identical, both having the same legal identity in the node, in the R3 network. And then lastly, we implemented MQ replication for the peer-to-peer connections in order to prevent loss of messages in case of node failure. Now, this design was implemented as a proof of concept to make sure it works. So we used Microsoft Azure in order to do this. Basically, each node was hosted on a virtual machine. We used an Azure SQL Server. Why? Because it comes with geo-replication, synchronous replication to other databases, and out-of-the-box HA basically. Other ways to do it was to just have whatever database you want on a separate virtual machine, but then you would have to implement HA by yourself, meaning have a cluster of servers somewhere, implement load balancing, replication. But this is already done by Azure SQL Server because it comes as platform as a service. Then another component that we use was the Azure file share for MQ replication. We thought that this was good enough performance, 14 to 16 megabytes transfer rates per second transfer rates. And it can also be configured to automatically mount during the VM startup. And lastly, in order to obfuscate the master and slave configuration inside the Corda network, we use an internet-facing load balancer, which acts as a front for the 2 machines and forwards traffic to the active machine in either peer-to-peer, RPC, or web traffic. So if we apply all of this to the design, the previous design, we end up with this diagram in which we can see both nodes using the same Azure SQL Server, using the same file share, message store, and communicating with the other nodes on the network through the load balancer. Configuring this was not exactly trivial, especially because no one has done it before. So in order to configure it, firstly, we had to set up the 2 VMs, assign IP addresses, and add them to an availability set, which was linked to the load balancer. So basically, the load balancer needed to know what resources there were available. The front-end IP address of the load balancer is advertised by both VMs A and B as their peer-to-peer addresses in the network. And then we needed 3 port forwarding rules for the traffic, each with their own health probes, which can be used to gather some health information and statistics. The next step was to set up the actual nodes. As stated before, both nodes need to be identical in almost every way. Both need to have almost same node configuration file. The only difference comes in the configuration of the mutual exclusion. We will see that a bit later in the demo. Both nodes need the same certificates because they have the same identity on the network, and also the same additional node info files and network parameter files, which describe the state of the network. Configuration, as said before, the peer-to-peer address points to the load balancer IP, the RPC and web addresses point to the local host, and of course the data source, it needs to be configured to use Azure SQL Server. Next is setting up the file share. By default, the master store files are created in the Corda home Artemis directory. The file storage we use, the file share, is actually a file storage account with locally redundant storage enabled. The type is general storage because Artemis can't handle blobs. For this proof of concept, we used standard performance, which is enough, HDDs with about 15 megabytes per second transfer rates. Azure allows the use of SSDs as well. And then, because we want to automate this as much as possible, the file share can be mounted up on each virtual machine as startup by editing the FS tab file. And below you can see the command that can be used to do this. Okay, next. So what we've seen so far is what R3 has done to implement high availability so far. We're currently at the hot cold step, working towards hot warm, and our goal is hot, and we hope to have that soon. We've seen that hot cold can be applied and configured using Microsoft Azure. Other cloud providers should work about the same, just identify whatever components they can use for data replication and load balancing, and should be fine. We've seen that the most important thing in hot cold, for example, is having a third-party database, mutual exclusion, message queues, replication, and flow checkpointing equals win. This has made hot cold easy enough. And immediate improvements for hot cold not only are failure detection and automatic master selection, because at this point, if the primary node fails, the only way of knowing it is if someone basically says the node has failed, I can't communicate, so please start the backup. We need to teach the RPCs layer how to load balance and make the node failure transparent to the RPC clients. And of course, we need to decouple Artemis components from the node and explore out of the box HA features for Artemis. And now I would quickly like to show you a demo of this design implemented in Azure. And let me just get this out of the way. So we have several virtual machines already created, set up, VMA and VMB, which you can see on this. Can you see on the screen?
No, I need to.
I need to go to Zoom and
share those applications, or just share your desktop. Yeah. There's a few questions. We can wait till the end if you'd like, or would you like to take them prior to the demo?
I could take them now if you need.
Yeah, sure. So let me start from the top here. So why not use Kafka as from remote?
Kafka as from remote. Well, we decided to use Microsoft Azure as Microsoft is one of our partners. It comes straight with, I mean, the file share is right there. It's easy enough to use, easy enough to configure. It didn't seem important at the time to explore other possibilities. This is just so the proof of concept is something that we have done. People may implement high availability as they please. If they want to use something else, they can. But again, this is just an early stage. We want to move forward to hot, warm, and hot, hot.
Right. Absolutely. Okay. The next question I'll take actually is there an ETA for IBM MQ integration? Not in the near future. That is something with pluggable message queue that we're working on. So we don't have a date to announce on that yet. That won't be in the first version of the preview you'd see, at least I can confirm that. It is dependent on wire stability, by the way, which is something that's upcoming in a near-term release. From Rob, is the Azure file store, whoops, sorry, just scrolled on me. Is the Azure file store an NFS share between the two nodes?
Let me just, what share?
Yeah, I believe that, under file share.
No, so the file share is a separate component somewhere in the cloud. We don't know about it in the data center. It is redundant. It has HAE on itself.
And I think if I interpreted this correctly, the question would be, is it one logical drive shared by both nodes, I assume?
No, it's not.
It's not, okay.
I mean, no, actually, it is. It's not a file disk. So Azure has a file disk as well, which you have to manually mount. The file share is
it's a network file share.
Yeah.
Okay.
Yeah.
All right. Excellent. Can the VM image replica work for hot cold?
Can what?
VM image replica.
Oh yeah, as in.
And I think that's what you're demonstrating today is hot cold, correct?
Yeah. So I have two virtual machines, one both with the same Corda node on them configured, and one will be shut down and the other one will be started and then switched.
Okay, great. And then there's a couple more small questions, but we'll take them at the end. So we'll jump into the demo now.
So we have two nodes running two simple Corda apps, the IU example Corda app, which can be found on GitHub. This node is, if I go get me, is Corda D. The legal name is Corda D. And this one is Corda HA, which sits behind the load balancer with the IP above. So, for example, I can't seem to get rid of it. Whatever. So basically, what I can do is I've already created some IOUs beforehand while testing this. It's easier to see from here. So I have three IOUs created, one with values 1, 2, 3. If I am to go to this node, which is not the HA node, and create another IOU, so the counterparty is Corda HA, and then let's say value 4. Create an IOU. Okay, so IOU was created, and then we go to this one, refresh. It's visible here as well. Now, let me just remember which one was the starting one. So this one is inactive, and this one is active. So if I stop Corda VMB, and I'll just reboot this one real quick. It'll take a few seconds. Basically, I should be able to, again, visit this page and see the exact same recorded IOUs. At the moment, it's connecting because it's rebooting. There's nothing there. one other thing that we need to improve is the startup time. Is not long, but it may seem so. Let's see if the virtual machine starts now. Okay, so it's starting now. Let's see the log files real quick. Make sure everything's working fine. Oh, something went wrong at some point. Filter. I hope this is something older. Oh, something older, sorry.
Okay, no demo has ever gone smoothly when it's locked.
So the node has started, Corda node is running in dev mode. Pro started, so it's starting fine. That was just another log. So let's try this page again. Okay, done as node. So the network map is being read. Okay. Okay, there we go. And we have all four IOUs created. So what has happened is we stopped the primary node and started up the new one, which resulted in the same states seen in the network, which is logical because we basically just started a new machine which points to the same database and file share in Artemis 2. So what I would like to try now is stopping this completely. So stop this. Go to the other node, click another IOU, let's say 5. Now, nothing's going to happen until I reboot the backup. And then after this works, I'll try something else, and in which I will run a small script which will just continue creating those IOUs, and then in the middle of creating the IOUs, we will just switch between machines and see that no IOU has been lost. Give it a few more seconds to boot up. Okay, there we go. Go to the Corda folder. Let's check the log file. Make sure there's no funny business going on. Okay, scanning Corda app. Corda node is starting up. Okay. Now, we should now see sometime soon a message here saying that the IOU with value 5 has been created. Shouldn't take long from this point. So this is where we see that the flow has resumed. Okay, there we go. So a new IOU has been committed to Ledger. If we go to the other one and refresh the page, we will, come on, go see it here as well. Now let's do something a bit more interesting, and that is RPC to the one of the nodes, and then just continue creating. Let's see, how many do we want to create? Starting from value 6, value, let's say 15. We don't want to take too long. So which one did I launch now? So this one is running. So let's run this real quick. I hope it works. Haven't done this today though. I'm just think it's a more interesting demo to see. So, okay, so we see some messages regarding the creation of the states, the signing, transaction, structural. Now let's stop this node. There we go. Now we should see that the messages will stop being generated because the connection has been lost. Let's give it a few seconds. As nothing else is going on. And then let's start this one. Yeah, funny thing, if you reboot an Azure VM like this, it takes a lot less than restarting it from the portal because it deallocates the resources and reallocates them, and it takes a bunch of time. So, okay. Okay, let's see if at some point the messages should resume being generated. Come on, let's go.
So while this is restarting, will this capability ship with the developer preview in the coming months?
Yes, or so? Yes. Excellent. Has been tested in the past month. Yeah.
Fantastic. So this is something that everybody can get their hands on in the near term.
Yeah.
And actually, we do have a few more questions. Well, we can use this time to address a few of these questions and commentary. So, I'm going to skip the containerization one, unless you actually bogged in with this here. This is we probably don't have the right people in the room for the containerization question. Yeah. So if you'd like to ask that on Slack, we'll definitely address that. And the next one is commentary. In the commentary, if those can't read it, there are tools like Jespin to automate and exhaust a set of sequences that are required for resiliency testing. How do you ensure that the hot-cold configuration genuinely doesn't have any data loss scenarios?
Well, every time, so we have a mechanism called flow checkpointing. So if there is some loss of data, there's not the total loss of data, the flows can be resumed from the saved checkpoint in the database. And again, by using third-party databases, we're kind of putting the responsibility of HA for that data on those third-party databases. So if you use a cloud provider, then they will offer HA for any type of database that you want.
Next question. Oh, sorry. What will be the supported databases by Corda? And I can answer that one. So, of course, H2 obviously in open source. In enterprise, we'll be shipping with SQL Server and Oracle initially as the two major databases. But we're always polling the projects that are in progress currently for what we test against.
Okay, so I think. Let me just check again. Okay, so it is working again. Have values 5, 6, 7. Am I not seeing the messages here? Just double check again if everything's working fine. Done anything wrong with the phone?
Any plans to support Postgres just while Bogdan's getting set up? Yes. So I believe that there was a Postgres contribution on the open source branch, which will be available. I believe it may have been merged, but we can check on the detail of that. And I believe Postgres will also make its way into the enterprise version. Although at this point, I'm unsure if we've actually tested and are certifying against Postgres in enterprise.
I should have prepared this a lot better.
And the commentary from Fuzz around exhaustively catching edge cases. Yes, and Richard's comment is we'll follow up with you, Fuzz, and make sure that we capture your thinking on that. So I'll drop you an email, and in fact, I owe you an email reply as it is.
So I apologize, something has gone wrong, I'm not sure what.
It wouldn't be a demo if it didn't fail, so.
Usually this works.
Okay, no problem, Bogdan. So apologies, everybody. We almost got there, but as any good demo always seems to fail when you do it live, so no problem. Bogdan, however, has committed, after following this session, we're actually going to be recording this same demonstration and putting it up on YouTube just as a short snippet. So we'll put up the fully operating one in a short form afterwards, so you guys can watch that in progress. So let's see if there's any other questions. Appears everything's answered. So thank you to Bogdan. Is there any other commentary, Bogdan? Otherwise, we can move on.
No, thank you for watching.
Excellent, thank you. And as Bogdan noted, this will be shipping in the enterprise preview program. So we will, for those of you that are registered, you'll see more information on this and the other capabilities in the very near future. So we'll send out an email blast to everybody who's on that list in the coming week or two. So the last news. So this is exciting news for us. We actually have some great facilities and a new office for R3, and we want to take advantage of that. It feels like the format of doing the webcast is a bit slow moving, and it's difficult to consume when you're on the road and such. So we're actually going to be changing this same content to a podcast format. So we're kind of excited because for those of us that live in London and take the tube, it gives us something to listen to. So we hope that it allows more people to actually get a hold of this content. So at the same time, we have some great video facilities now. So we'll be putting out more content. So you'll see more of the same content from the AWG, largely focused on distributing it on Corda.net and up on the YouTube channel. And then we'll be transitioning from this webinar format and going to a podcast format in the coming weeks. So for all of you that are registered, we'll send you an email link to the podcast and help find your way over there. And then, of course, for the interactivity and questions and such, we do monitor YouTube. So when we post videos, we'll try and answer questions up there. But also, you can always find us on Slack. That's a great way for the bigger questions. Charles is asking no visuals in the podcast. But a lot of the content you're seeing in the AWG, the same content will continue with visuals. We'll largely be doing videos just so we can turn them out quicker. We're trying to be less formal about it to get more information in your hands. Podcast non-interactive. No, we still, Slack is our primary interactive channel, and then we'll try to respond to questions in other formats also. So we'll send out some information there. So thank you for your time, everybody. What is the Slack address? Actually, you can find our Slack channel. It's a great point. Thank you, Michael. So Slack, the Slack channel is up on Corda.net. So you can see at Corda.net, you'll find all the links to these various pieces of information. So the Slack channel is up there, the public Slack channel, a link to our YouTube channel, and then shortly you'll have a link to the podcast. So thanks for your time, everybody. We will see you on our various channels. So thanks for joining us, and we'll talk to you again soon.